CSC 480 Artificial Intelligence 1. This is assignment number 1. So when you run the program, this console will pop up and you enter commands into the console and it will print the results to the screen. It will also print the results to a text file. So in this case, 1 for breadth first search, 2 for depth first search, and so on and so forth. 9 changes the state to easy, the initial state to easy, 0, medium, and A to hard. So let's run one real fast. I'll run breadth first search on easy. It prints the results out, and I'll run a A3 algorithm too. That's 8, and it print the results out, and you see them right there. And if you go to the source file, you will see these files were generated, and here are the results. And that's how you do it. You can change the state. I'll change to medium, and I'll run, I don't know, A2, and there is A star 2. All right, that's the program. Any other command quits. So that's that. Let's look at the code real fast. So here's my main function. It basically runs into a loop, and it's looking at the commands that you're giving it. And here are all the commands. So 1 for breadth first search, 2 for depth first search, and so on and so forth. It puts it in a switch command, and I have this 8 puzzle object, and basically it just calls a function based on your commands. And that's what that does. Looking at this 8 puzzle object, here it is. It has an interface for all of the search and algorithms and to changing your initial state. It uses a hash table. I have a custom tree that I made and a message queue for sending messages to the console and to the file, and my initial state. So if we look at the I have these helper objects too to help me do everything. There's a state object that just holds 5 or 9 integers for the values on the board. A board that helps me determine what moves can be done. A state node. This is the basic node to my tree, and it can be pushed on my custom queues and stacks. Very simple stack. It collects the state nodes. Very simple queue that collects the state nodes, and a priority queue. And then this messaging queue is just for printing the files and stuff. All right, let's go over the search algorithms. Breadth first search, pretty simple. You push the root of the tree on the queue, and it goes into a loop. It doesn't stop the loop until it finds a goal. It will pop the value off the queue, and if the value is the goal, we're done. If it's not the goal, that node gets expanded, and all the children that are expanded go back on the queue, and it just repeats until it gets a goal. And it uses a queue, so it horizontally keeps moving until it finds a value. Depth first search is almost identical to breadth first search, except it uses a stack instead of a queue. So it goes down the very far left part of the tree until it finds a value. Iterative deepening is similar to depth first search, except it keeps track of a depth value, and if it doesn't find a value, then the depth value gets incremented and everything is reset. And it keeps doing that until it finds the value. Uniform cost, there's a weight associated with each node. I'm using a priority queue, and this weight has to do with, where is it? The parent weight plus the value being moved. Best first search is the same thing like the uniform cost, except it's the heuristics, the first heuristics, the positions on the tile that don't add up. A star heuristics 1 is similar to best first search, except it's H1 as well as the depth. So a combination of the two. H2 is the same thing as H1, except it's the heuristics 2, the Manhattan distance, plus the depth. And my A3 is a combination of H1, H2, and the depth. And that's really it, and everything else is a helper function. My expand node, I just determine if I can move left, right, up, down, and I set up the nodes here. Initialize the tree. I free all the memory. There's no memory leaks here. I do use heap memory, and I'm using a design pattern, the pool object pattern, to get nodes. And that's the assignment.